All right, so we are about to get started. Make sure that you are wrapping up for sure. I had given those students some extra time to wrap up on the board. Make sure you're wrapping up at this time. You should be taking your headphones off so that you can pay attention to the lesson today. It is no longer independent work time, so take your headphones off. Today's lesson, albeit, like I said, most students in the past years and this year, this is the last class I'm teaching this in this year, have found this lesson to be one that they really like. So I hope the same will be true for you. You'll tell me afterwards if it's one that you're like, this is good or no. But most of the time, and I guess it's juxtaposition, it's a big word, but naming kind of gets ruling over time. And so hopefully you'll find this to be a significantly easier idea to absorb. The problem with naming is that it's a lot to memorize, whereas in what you're going to do now, it's not a lot to memorize, but it is a technique you're going to have to learn. So once again, the lesson now is Unit 3, Lesson 4. We're going to be learning how to draw Lewis structures. Before we start that, I want to go over some class announcements just to remind you what's going on, what's coming down the pike. So let me get the door real quick first. Okay, first things first. In this class period, there was a quiz last class. If you didn't already check the grade book, make sure you do to see how you did. There were a decent amount of good scores. Not everybody did amazing, but that is actually typically normal, unfortunately, for naming because it's just something you got to memorize a lot of stuff. And so that is the big bulk of the memorization for this unit. There is one other topic that is going to require memorization, but it's not going to be one we're doing today. Like I said, today's more going to be a skill that we're going to need to learn. Now, if you missed the quiz, like I said, there were 4 or 5 students that missed the quiz. I want to remind you of what the class policy is on making up quizzes. First, there are 3 ways to do your makeup quiz. The first is actually come to tutoring. Any day that I have tutoring after school, whether it's for pre-ACE or for ACE, if you just need to take a quiz, you can come during tutoring to make up a missed quiz. Tutoring is Mondays and Tuesdays, so that wouldn't be until we get back from fall break. Second option is to come during lunch. Now, for lunch, if you are going to come during a lunch period, you have to organize that with me beforehand. I have to be here. I have to know I have to be here, and I have to be available to be here during lunch, which I'd say like on most days I am, but I can't be in this room every minute of every day all the time. So you have to organize with me in advance. If you missed your quiz, you can't stay after school, and your option is to come during lunch. Make sure that you organize that with me. Like I said, there's 4 or 5 of you that need to make up the quiz in this class. The third option, this is my least favorite, but it's out there if you have to, is to make up your quiz or exam, if you miss an exam, same thing, during bell work for any class period, meaning that you are missing out on that opportunity to either review what we've been learning with the quizzes, and also potentially if it's an exam, you're going to miss part of the new lesson, which means you're now behind. And so this is definitely not my preference for you to do it during class, but if there's no other option for you, then you got to do what you got to do. So that is the third option. Just so you know how I work with putting in zeros, I always give a week grace period for the most part, unless there's an exam like and the quarter's about to end, then I put in a 0 just to make sure you know, hey, got to do this, got to make this up before the end of the quarter. But typically I'll give a week for you to organize. So week to figure out when you're going to take it. If you organize with me within a week of your missed quiz, when you're going to take the quiz, you reach out to me and we either organize a date. You tell me you're going to be during this date during class or during this date during lunch. You give me that heads up within a week. I'll hold off putting a 0 in the grade book and let you take the quiz and then just put in whatever the grade is. But if after a week you haven't talked to me about when you're going to make up your quiz, I got to remind you that that quiz is still out there. So I'm eventually going to put in the 0 after a week. So I put in the Z after a week. Does that mean you can't ever take the quiz? No, it just means you need to go take it to fix the grade in the grade book. Got it? Yes? Make sense? Okay. Also, if you're like, I never want to take this quiz. I've got 30 points. Can you do that? For a quiz, sure. If you've got 30 game points, you gotta have 30. You have 30 game points, you can decide you don't want to take that quiz. I don't want to learn naming compounds until the unit exam. I'm gonna X that. But what that does is it means that the other quiz is now gonna be worth double for the quarter. Does that make sense too? Plus you have 60 points, you want to exempt everything. But then everything's on your unit exam, which isn't an ideal place to be either, because that's the big test that involves everything, right? So, just wanted to go over that. Quiz was last class. It was on naming compounds. We're not going to be looking at naming compounds again until we're reviewing for the unit exam in December. We are moving on to something else. I'm sick of it. I'm sure you're sick of it. It's important, but it's important like just in passing. You need to, if I tell you what potassium, I'm talking about potassium iodide and a chemical reaction, you need to know what I'm talking about. So that's why we went through that. Alrighty. So the next thing is I'm recording the lesson. So I usually don't record in this class. However, in B days, there was banging on the roofs, like really bad banging when I taught this lesson on B day. So I didn't record there. And then third period today, I tried to record but forgot. So I'm recording in this class period today for this lesson so that I could post it after school for anybody who needs to catch up or rewatch on the lesson. I do like to tell in advance if I am recording, just so you know, you're the lucky class today. All right, so here we are, officially beginning Unit 3, Lesson 4, Drawing Lewis Structures. So make sure you have your notes out. You will want paper notes for today, unless you're going to be drawing on an iPad. You will want paper notes today, because what we're going to be doing is drawing molecules, actually. How do we draw them properly? Oh, your arm? Okay, so just pay careful attention and do what you can when I post on. Okay, so as we get started with this, the first thing I want to bring up is that Lewis is the name of a scientist who proposed the theory, and so that's why we call them Lewis structures. Another name for Lewis structures that might ring a more familiar bell to you is electron dot structures. So let's write here, we need to review how to write out electron dot structures. In the first lesson of this unit, I actually did teach how to do electron dot structures for atoms and for ions, and we talked about when we form ionic compounds that the metal would do what with its valence electrons? It would give them away, and the non-metal would receive. And we showed those electrons being transferred over, right, with the electron dot structures. So now what we're going to do, and this is a really, really big topic, is we're going to learn how to draw electron dot structures for covalent compounds when electrons are shared instead of transferred. And so beforehand, we need to review. Well, how do we get the electron dot structure for an atom? If I said I had, let's go with nitrogen. How do I know how to write the electron dot structure? Do you remember? What would we do first? So first we would need to find valence electrons. Are you okay with me writing VE for valence electrons? Because I don't want to write too much. So find your valence electrons. How many is that for nitrogen? So we got to look at that periodic table. We go to the group. Remember, valence electrons are not the same thing as the charge. Valence electrons is how many electrons are in the outermost energy level. The charge is how many are needed to become like the nearest noble gas. So how many valence electrons does nitrogen have? it has 5. So you want to write that out. And then remember that in electron dot structures, electrons are written as dots. So how would we write the dots around nitrogen? Do you remember what to do next? Until you fill? Correct. Perfect. So 1 electron on each side, right? Until all sides are full, and then you keep moving. Right. Until you run out of electrons or you reach 8. On each side until all sides have 1. Then you can fill. That's so much I'm writing. But that is exactly what you have to do. And so what that really means is if nitrogen has 5, we're going to place 1 on each side, 4 sides, left, right, top, bottom. And then the 5th one, doesn't matter which of the 4 sides we choose. It doesn't matter. Most people, like standard, is to write it at the top. But if you wrote it at the bottom, the left, or the right, I would accept all of that because it's technically all correct. And you'll see in today's lesson that you will be able to move electrons around the same atom when we're drawing full structures for covalent molecules. So it's important to have that note. So atoms, that's what you do for the electron dot structure. Now what if you have an anion? Let's specifically shout out the anion for nitrogen. What's nitrogen's anion? What's the charge of nitrogen when it gains electrons? It's going to be N minus 3. And so how would we write the electron dot structure for the anion? What would we do now? Anion means add 3 electrons, right? So you would have the original 5, but then you would also have 3 more added. And if we were going with Cambridge, we would use a different color or different shape to indicate this. I'm just doing that. You can do it in pencil, it doesn't matter. But in the AICE class, I would tell students to designate with a different notation that we have added 3 electrons. And so I wrote them in blue here. These are the 3 added ones. Well, how many total electrons is that now around nitrogen? Is that an important number? That's called the octet. And that means that nitrogen has the same amount of valence electrons as the nearest noble gas. Which means that nitrogen would be stable, not neutral, but it would be stable. And so that's how we do the electron dot structure for an anion. We basically just add the electrons, and every time it's going to add up to 8, because that's the point of adding electrons, is to get to the amount of electrons as the nearest noble gas. All right, what about cation? What do we do here? What if we had Mg with a 2+ charge? What would that electron dot structure look like? Correct. Because magnesium had 2 valence electrons, but when you say 2+, you're taking the 2 electrons away, so you should write no dots around a cation because those electrons went somewhere else, maybe to nitrogen or another anion. Make sense? So I wanted to review this because it's going to be the fundamental basis of where we're beginning today's lesson. We're going to be drawing these electron dot structures, which we are now going to call Lewis structures. It's based on a scientist's name. We oftentimes name ideas and theories and structures and models after scientists. But we're going to call them Lewis structures. And it's basically drawing electron dot structures for covalent compounds. How do molecules form? It's an incredibly important topic, and it's important no matter what science you take after this. This is going to be important to the study of environmental chemistry, or environmental science, to marine science, to ACE chemistry, and to ACE biology. So it doesn't matter which science you take. This next set of topics is super important for all of it. I cannot tell you how many times this guy told me, you're working on water and they're not drawing the structure correctly. So make sure that you're paying careful attention to what we are about to do. All right, so we've got a couple definitions that we always have to work through before we get to the main goal of the day. So this is the first one. You do not have to write the diagrams, please don't. This is not how they're going to look like for you. These are full bore models, and we're only going to look at the valence shell. So you do need to write what's here. In covalent bonds, electron sharing happens for the same reason in ionic bonds, electrons are transferred. The goal, like always, is for an element to be like its nearest noble gas. That's what's going to formulate stable compounds. So the difference between an ionic bond and a covalent bond is that whereas in an ionic bond, an electron is given away from one element to another element, in a covalent bond, instead electrons are shared between the two elements. That is the main difference between the two. So this is not an electron transfer, this is electrons being shared. And electron configurations of noble gases, this is pretty much the same. All elements are stable with full valence shell. When they have the maximum amount of valence electrons they can have. The maximum amount is 8 for most elements except for hydrogen. Hydrogen is the exception. How many electrons is hydrogen stable with? 2. And you're going to have to remember that throughout today's lesson. There you go. So you got a preview in the ed puzzle. What does this electron sharing look like? But we're going to create it from scratch. How to go through and draw these electron dot structures. I'm giving you some time to finish writing this down. I'm just giving you a heads up in about 20 seconds. I'm planning to move forward. You do not have to write the diagrams at the bottom, please don't. All right, I am going to go ahead and move forward now. So a lot of our leading information that we need is here. Both of these definitions and the diagram that you see here is important to write. I'm going to explain this shortly, but I'm going to give you some time to get this in your notes. You'll see the first definition says that when two atoms are held together by sharing a single pair of electrons between them, we call this a single covalent bond. And then what's shown to you with the diagram here is how we're going to create our Lewis structures. A fluorine atom and a fluorine atom, the two electrons here, the single electron and the single electron here, combine, and we write a line between them to say that both of these electrons are shared between both of these fluorine atoms. That's what I said. Go ahead and write down this diagram along with the two definitions, and then I'm going to explain more shortly. I'm going to give you some time first. I'm going to describe why, how, when this happens. You'll see why I wear a little black now. Lighting the closer. It is blue. Yes, Michelle.
Do you have to draw the picture?
Yes. The diagrams need to be drawn here. I am going to redraw it and create it from scratch. So if you need to, you can wait for me. But everything here is important. I'm just pausing to give you some time. But we need to talk about what's actually happening here. So what we're describing is, for nonmetals, how they're going to combine to form stable molecules. What we have learned about nonmetals in terms of what they want to do with their electrons is what? What does fluorine want to do? Gain or lose electrons? Gain. Everyone agree with that? Fluorine, so you've got a fluorine atom here, and fluorine wishes to gain electrons. What about the fluorine atom to the right-hand side? Does that fluorine atom wish to gain or lose electrons? Also gain, right? One of the things that we learned is that nonmetals want to gain electrons. So, question, will the fluorine on the left be able to steal the electron from the fluorine on the right? What do you think? No, because they're both as strong as each other. They're the same element, right? They're both as strong as each other. They both desire to gain electrons. So one is not going to be able to steal the electron from the other. But fluorine needs to be stable. So how can we make that happen? If one element cannot give and the other one receive, what is your other option now? Sharing. So what happens is, fluorine here has a single electron, and fluorine here has a single electron, and those two electrons are going to be shared between the two atoms of fluorine. And so whenever you see a single electron, you bond it with another single electron, and it makes what we call a shared pair of electrons. And what do I mean by shared pair, by that terminology? That means that those two electrons that belong to both atoms. So whenever you draw a line between two atoms, you connect those two single electrons, you're actually indicating that these two electrons are being shared between these two fluorine atoms. So whenever you see a line, that's called a single covalent bond. And it means two electrons shared between two atoms. So now, instead of fluorine, by sharing its electron with the other fluorine, instead of fluorine feeling like it has 7 valence electrons, yes, sir. Go see if you can find it. Instead of fluorine feeling like it has 7 electrons, now fluorine feels like it has how many? It has 1, 2, 3, 4, 5, 6, but then it feels like it has both of these two. Kind of make sense? So you count the bond as how many electrons? 2. So fluorine now feels like it has 2, 4, 6, 8 electrons, like its nearest noble gas. And so fluorine is stable. Now the next terminology you need to understand is something called an unshared pair. That's the one on the bottom. A pair of valence electrons that is not shared. Do you see any pairs of electrons on the fluorine example on the top that are not shared between the two fluorine atoms? They only belong to one fluorine atom. Do you see any pairs of electrons like that? Well, first of all, what's a pair? If I say I have a pair of shoes, what does that mean? I got 2 shoes that are together, right? same shoes, one left foot, one right foot. So circle this. This is an unshared pair. Whenever you see two dots, that stands for two electrons that belong only to that fluorine atom, not the other fluorine atom. So, given that I've told you this information, in this molecule of F2 that we see drawn, how many unshared pairs in total are there? Can you count them? To figure this out, you could do it by circling, but you just gotta count how many two dots you have, right? So 1, 2, 3, 4, 5, and 6. You have 6 unshared pairs of electrons. How many shared pairs? 1 shared pair. We are going to be, as we work through examples, counting our shared and unshared pairs because this actually determines the shape of the molecule when we get later on into the unit and the polarity of the molecule. I don't know if in biology you've heard of polar or non-polar before, or hydrogen bonding. All those properties of water actually depend on the structure that you draw. So this is all going to lead into very important ideas as we go through this unit. We're establishing what we need now. Key terminology to be able to do what we're going to have to do later, predict later. All right, so I think we have just 2 more definitions before we get to the main goal of the day. What do we have to do? This, I know that I did not go over in this class because we were a little bit behind. So we have just to discover what is a molecule and what is a molecular formula. A molecule is what we call the simplest unit of a covalent compound. Meaning, if I have, for example, 1 carbon, what would we call 1 carbon? What is the simplest building block of an element? What would we call that? An atom, right? So if I say I have 1 carbon, I know that it's 1 carbon atom. If I say I have 1 water, water is not an atom because it is not single. So far, so good. So we give it a different name. The different name is called a molecule. So if I say I have 1 water, I have 1 water molecule. So what we're going to be drawing in today's lesson are molecules. So molecules are a group of atoms that are joined together by covalent bonds. And so they're basically, molecules are to covalent compounds as atoms are to single elements. They're the smallest unit of a covalent compound. We call it a molecule. So if I say I have 1 CO2, 1 carbon dioxide, I have 1 carbon dioxide. We don't call it an atom, we call it a molecule. So it's just understanding when I'm talking about molecules, I'm talking about the smallest of a covalent compound. One of that covalent compound, yes. Mm-hmm. And the definition on the bottom is a molecular formula. It's a little bit of a silly definition, but I go over it because it does come up here and there. It's a chemical formula of a covalent compound. So what does that mean? Chemical formula you were asked to write chemical formulas on the last quiz, last class. What is that? What's a chemical formula? I told you you have to go from name to formula and formula to name. What's a formula? What? Yes. So what is it? It's just how many of each element you have, right? So chemical formula would be something like NaCl. It could be something like PbSO4. I know chemistry jump scare. We learned that when we were naming. But really, all the chemical formula is the compound formula. How many of each element do you have in the compound? call it a molecular formula instead when the type of compound we have is a molecule. So molecular formula would be used for water, for CO2, for N2O4. For covalent compounds, we call them molecular formula. It's the same idea. It's just how many of each element do I have? Again, this is terminology that trips people up, which is why I like to go over it. What does it mean? Because you'll see it here and there in questions on quizzes or multiple choice questions, and you need to know what it means when it shows up. So a chemical formula can be used for ionic compounds. A molecular formula can only be used for covalent compounds, because molecules are covalent compounds. All right, with that being said, as you finish writing down these examples, I have your handout, which is, make sure you write when you get this paper, Unit 3, Lesson 4. This is getting to the main goal of the day. What are you actually going to be asked to do? What is and this is actually a really important skill in chemistry. The first important skill you technically learned in this class was electron configuration. Remember when you did that 1s2, 2s2, 2p6 thing? That was the first skill that you're expected to know out of a high school chemistry class. The second major skill is what you're about to learn today. So I'm passing out the paper with how to draw Lewis structures, and then we're of course going to go over many examples together. Somebody raise their hand first. Go a little bit. First one. There you go. There you go. As I'm about to go over this, the next topic, what we're about to do, you should use a pencil. If you have a pencil, get a pencil out. If you don't have a pencil, I'm going to go around and pass out some pencils for those who need one. For this next set of examples in the lesson, you're going to want a pencil. All right, so with passing these papers out, I've hopefully given you enough time to do this. So let's go ahead. We're going to go over the strategy. How to draw a Lewis structure for a covalent compound. Here we go. These are steps. In this class, you should remember, I got the door. You should remember that whenever I give you something that's some steps you need to know, this is something you are going to have to memorize. Now, just to throw out a number, because I've already done a couple of classes of this with B-Day, you're going to see 30 to 40 examples over the next few class periods between the examples we do together and the examples you do on your own. So do you think you're going to memorize 3 steps over 30 to 40 examples? I would hope yes. I would hope you do. And this is something that's rehearsable. They're the same steps each time. So raise your hand if you'd like a pencil for me. Yes. Raise your hand if you'd like a pencil. You do need a pencil as you're drawing these, especially once the questions get more difficult. So you're going to want paper and you're going to want a pencil so you can go through the technique. Michael, you brought the pasta? Yeah. All right, so let's go over the rules, then we're going to apply them. First step in drawing a Lewis structure. Somebody in B-Day had asked this, so I'm going to answer a question that you probably haven't even thought of yet. What you're going to be given in these questions is a chemical formula when you're asked to draw Lewis structure. So for example, you're going to be given this, CH4, and you're going to be asked to draw how do these atoms bond together correctly. We call that the Lewis structure. The question I was asked in B-Day was, would I give you the name instead of the chemical formula? Like for example, would I give you carbon tetrahydride and ask you to write the Lewis structure? And I was like, man, I didn't even think that's a good idea. But no, I'm not going to do that because I've already assessed your ability to name. I don't think it would be fair to make you do that along with this new thing. So you are going to be given the chemical formulas, which means you are going to be given the amounts of each atom, and then you just have to follow the strategy here. So somebody had asked me in another class, that's why I'm addressing it. So here are the steps. You're given a chemical formula. How do you bond the atoms together? The first step says the first element listed goes in the middle. We don't know what that means yet, maybe, but it goes in the middle. And all the other elements surround the first element. The exception being hydrogen. You should underline that and say hydrogen can never. This is a cardinal sin. Can never, ever be in the middle of a molecule. Never. Anybody want to guess why not? Well, hydrogen has how many valence electrons? So how many connections can it make? It can make one bond, right? It can make one line to another element. So can you put more than one element around hydrogen given that it has no other electrons to connect? No. Hydrogen must always be at an end of a molecule. If you put it in the middle, just know you're wrong. It's just wrong. That's one of the ways I know I can look at your answers. Like I look at your work, and in 5 seconds I can tell if it's right or it's wrong. Because I know these are right. All right, so that's the first step. Step is first element listed goes in the middle. All the other elements surround the central element. The exception being if you see hydrogen listed first, do not put it in the middle. Still put it on the outside. Step 2, draw the electron dot structures for each of the atoms. Now there is a rule of thumb here. This means you don't have to do it this way, but I strongly encourage you, if you like getting questions correct, to do it this way. The rule of thumb is to face single electrons towards other elements and face pairs of electrons away. Yeah. Okay. And the third step is to draw bonds. What do we mean by bonds? These lines between two electrons. Draw bonds between single electrons. You want to underline single electrons. Those are the only ones that can form regular bonds until each element feels like it has 8 electrons. The reason it's 8 electrons is why again? Octet rule, nearest noble gas, with that one exception that we got to know being hydrogen. Hydrogen only needs 2 instead of 8. So far, so good? So these are just the steps. You're going to keep this paper out with you because until you've memorized it, you're going to need to follow the steps. Here we go. Ready to see first example? Now, here's the thing. Today, I'm only going to show you level 1 and level 2 examples. Level 1 is the easiest I could possibly make a question. Level 2 means you got to do a little bit of extra thinking. A little bit. Level 3 is actually what you will see on the extra credit portion of your next quiz. So when you take your next quiz, it's going to be out of 120% instead of 100. And everybody in the class will have the ability to earn 120 because I'm going to teach exactly what you need to do for that level 3 type question. It's just whether or not you're going to do it or not, whether you get the 120. But it's totally possible for, I would even say, a good portion of the class to get over 100% on the next quiz. Yes. Hold on. Let me make sure. Somebody just, I think, left. When that student comes back, you'll be next. All right, so clear. Today we're going to cover all the types of questions you're going to see on your next quiz. You're going to see all level 1 and level 2 type questions. When we come back from break, so today's like the last day before fall break, so I definitely would not want to give you something difficult before fall break. So everything we do today will be classified as hopefully pretty, not too bad. We'll see the more difficult questions when we come back. But those more difficult questions would be considered extra credit. Okay, so everything you need for the quiz, I'm actually going to teach today. We'll practice next class. You'll practice with homework, and then we're going to look at more difficult questions next class period. So let's go ahead and see, what do level 1 questions look like? And I do want you to write the level next to the question just so you know what would make a question level 1, level 2, and then next class we'll look at level 3. So, level 1, meaning I cannot possibly make this question any easier. This is as simple as I can make it. Draw the Lewis structure for the following, NH3. If we can follow the steps and figure out the correct way that nitrogen will bond to 3 hydrogens to make a stable molecule. So step one. What does it say? First element listed goes in the middle. What's the first element listed? And we're meaning left to right. Read it left to right, like you're reading words on a paper. Nitrogen. Nitrogen can go in the middle. Put it in the middle. Nitrogen goes in the middle. The only element that cannot go in the middle is, please don't do that ever. I'll cry on your quiz. Especially if I'm sad already. Nitrogen goes in the middle. What goes on the side now? How many do we have? We have to follow the amounts, right? Only write the amount you have. I see students messing up on this already. 3 hydrogens means 3 hydrogen atoms. So how many sides of nitrogen can we imagine there are from what we remember from electron dot structures? Do you remember it's 4, right? But I have 3 hydrogens to place. Does it matter which of the 4 sides we choose? No, because molecules move. They're actually 3-dimensional objects. So it does not matter which side you put the hydrogens on. Typically, people do the left, right, and then the bottom. But if you wanted to be spicy, you could do top, bottom, and right. Like, it doesn't really matter. You pick any 3 out of the 4 sides to place the hydrogens. A maximum of 4 sides. So far, so good? Think of your electron dot structure to remind you of where your sides are. Left, right, top, bottom. Step 1, we did it. Step 1. We arranged the atoms how we think they're going to connect. The first element listed goes in the middle, the other ones go around. Second step. This is the one that students like to skip. Don't skip this step. The step is to give each element their amount of valence electrons. If you get the amount of electrons wrong, you're just wrong. I'm just going to throw that out there. So don't skip step 2. I know you're going to want to, so do it. Don't do it. How many valence electrons does nitrogen have? 5. And how many does hydrogen have? 1. This is all you got to work with. You have to work with these numbers. You can't just add extra electrons because you feel like it. You can't just erase electrons off your paper because you feel like it. You have to work with nitrogen being 5 and hydrogen having 1. And how many do they need to feel like they have at the end of this process? 8. So this is what you got to work with. So how do we write these electron dot structures? The rule of thumb I gave you is if you have a single electron, that means 1 dot, face it towards another atom. If you have 2 dots, that's an unshared pair, you face it away. So hydrogen has 1 valence electron. The hydrogen on the left, I'm going to put my electron there. My single electron faces toward the atom that it's next to. This hydrogen, I'm going to put my single electron here, facing towards the nitrogen. This hydrogen, I'm going to put a single electron here, facing towards the nitrogen. So far, so good? What about nitrogen's 5? How should I place nitrogen's 5? How many facing the hydrogen? Step 5, right? So place 2 at the top, 3, 4, 5. 1 facing a 1, 1 facing a 1, 1 facing a 1, and then 2 that are alone at the top. The pair faces away. reason why we do that is because of step 3. Step 3 says to draw bonds between single electrons until every element feels like it has 8. Yes? So, a little jingle that I like to use to remember this is single electrons are ready to mingle. So a little jingle I like to do is single electrons are ready to mingle, just like, single people can mingle. Pairs should not be shared. If you're in a pair, you should not be shared, right? Pairs should not be shared, but singles are ready to mingle, to form that relationship, to form that bond. So, just you remember it. So singles can mingle. Pairs should not be shared. So, hydrogen has a single electron there. Nitrogen has a single electron there. Could they pair up? That's a single, that's a single. Can they bond together? Yes. You draw a line. You're literally connecting 2 dots. You draw a line between the 2 single electrons, and now these 2 electrons are shared by both of these atoms. So far, so good? Okay, go to the bottom. That's a single electron on nitrogen. That's a single electron on hydrogen. Can those 2 atoms share those 2 electrons? Yes. Remember, singles can mingle. Single electrons, those can form bonds. Over to the right-hand side. Can this single mingle with that single and make a covalent bond? Yes. And that pair should not be shared. So that's it, actually. You're done. But how do you know? How do you know it has 8? You know how to count it? Look at nitrogen. Remember, every line counts as how many electrons now? So 2, 4, 6, 7, 8. Nitrogen has 8. What I usually do is put a little check mark. I'm like, yep, that's good. Good to go. And now hydrogen over here has how many? 1, 2. Is that okay for hydrogen? Is hydrogen okay with having 2? It's supposed to have 2. It's supposed to be like helium, right? So each of these hydrogens are good to go. And we know, and that's why I said a lot of students actually like this topic better than the last one, because you're going to know if you're right or if you're wrong. Like if you do your count, you're going to know right away. You're going to be like, oh, that counted to like 7. That's not right. Or you're going to do your count to 8. You're going to be like, oh, yeah, I got it. So you can self-check yourself on all the questions. Jose? And then Steven? All right, Jose first. Sorry. All right, are we good with this first level 1 question? So there's another type of thing you should evaluate here before we go to our next question. How many shared pairs of electrons are there in the final answer? How many shared pairs? 3. 1, 2, 3, right? How many unshared pairs? 1. That is definitely something you'll need to evaluate later on in this unit. So that's why I'm bringing up the idea, because we have to use it for something later on. All right, we're going to move on to take a picture of it. We're going to move on to 2 more level 1 examples. Then we're going to take a look at level 2. So the thing about the level 1 examples is level 1 examples, if you follow the steps blindly and do no thinking, they will always work out. Like no matter what, it's going to work out. You don't have to do any additional thinking. Level 2, we got to start thinking. All right, so level 1, VR2. What about this next example? What do we do in the first step? How many bromines do we have here? How many bromines do we have? That's 2. What do we do if we have 2 atoms? Is there an element in the middle? What do you do if you got 2? Put them next to each other. So there is no central atom. There's just one on the left and one on the right. That's step 1. Step 2. Don't skip this step. What's the next step? We got to figure out bromine's valence electrons. How many?
7.
Group 17, take away the 1. Amount is 7. First good? All right, so we use that to get the electron dot structure. Face pairs away, face single electrons toward other atoms, right? So we're going to do 1, 2, 3, 4, 5, 6, and that 7th one goes that way. And for this bromine, we go 1, 2, 3, 4, 5, 6, and the 7th one goes that way. Make sense? We have finished step 2. Step 3, angle your singles. So all that means is this single electron and that single electron, can they bond together? Yes. Is this the correct answer? Yes. How do we know for sure? Count. Every line counts as 2 electrons because they're shared electrons between both elements, and every dot counts just for that atom. So bromine on the left-hand side has 1, 2, 3, 4, 5, 6, and the line is 2 more, so that's 8. So that's good. And this bromine is the same thing. 1, 2, 3, 4, 5, 6, and 2 electrons is 8. It's good. The next one, H2O. Hey, what's that? Water! If you move on to AICE Marine Science, that's your choice after this. Because remember, after Grace Chemistry, you get a choice of whatever AICE Science you want to take. You're going to have chapters on water. And Miss Jadine is going to expect that you know the structure of water. It's just going to be really sad if you don't. So what is the structure of water? What's step 1? What goes in the middle? Oxygen. Thank gosh you did not think. Oh. No, hydrogen never goes in the middle. Please do not put hydrogen in the middle. Okay, oxygen goes in the middle, right? Which means hydrogen goes on the, doesn't matter which side. Not really. We usually just do left and right just that. But it doesn't really matter. Left and right. That's step 1. What's step 2? Yes.
Pardon the interruption.
Yes. Okay?
Can you send Kaylee's science to the main office for 1 minute?
Just for 1 minute? Okay, Kaylee, go ahead. Oxygen has how many valence electrons? Step 2. Oxygen has how many valence electrons? 6. Hydrogen has 1. So the 1 for hydrogen goes that way. The 1 for this hydrogen goes this way. Remember, your single electrons always face towards the other atom that you're trying to connect it with. And then for oxygen 6, next for the bathroom. Go ahead, Stephen. Oxygen, we got 6 to place. Is this going to work out? Here's a way, 2, 4. 1 on the left, 1 on the right. That's step 2. Right? We just place our valence electrons. That's step 2. Now, step 3 is where we work it out. Is this going to happen? Our singles are going to mingle. They're going to combine together, right? So you've got this electron and that electron, and they can connect. They can bond. Which means now these 2 electrons are shared between these 2 elements. They are bonded together. On this side, that's another single, so they're also going to form a covalent bond, right? They're going to mingle. Is this good? Does this work out? Yeah, that's water. That's the structure of water. That's how it should look. You look it up on any Wikipedia or textbook page, it better say that. Those are their rock. That is the structure of water. We still good? We're okay? That was level 1. We are now going to look at level 2. So, what is the difference between a level 1 and a level 2 question? I told you you'd have to do a little bit of extra thinking now. So, what is the first place where you might have to think extra? I'm going to give you the two scenarios where you have to think extra. The first one, you saw it in the video. Anybody bring up what we haven't looked at yet, but it was definitely in the video. Go ahead. We have double bonds or triple bonds. So the first type of level 2 question is if you have to use a double bond or a triple bond. So we have to figure out when do we have to do that. So write this down before we do the next set of examples. We're going to look at why, when, and how atoms form double or triple bonds. The reasoning is that if this is the only way they can get to become like their nearest noble gas, by sharing 2 or 3 pairs of electrons instead of just 1. So instead of 1 mingling that's going to happen, there might be multiple minglings that are going to happen between 2 atoms. And that's what we're going to be evaluating now. So go ahead and write this down, and then we're going to take a look at our next set of examples. We're encountering now double bonds and triple bonds. Giving you about just 20 more seconds, but actually let me go ahead and specify this. So what does a double bond look like? This is a double bond, just to be clear. That's what it's going to look like. So I'm going to give you a little bit more time because I'm specifying exactly what this is. And a triple bond looks like we're going to take a look at when, how, why would we use a double bond or a triple bond instead of just single bonds. All right, we're going to do 3 examples of this type. And then there's one more level 2 type of question you need to be familiar with before we go. Ready? 20 seconds, heads up. Moving forward. Have this paper out, the steps are still the same. Just gonna have to do a little bit extra thinking. All right, draw the Lewis structures for the following. Do one at a time, leave yourself space for each one. Draw the Lewis structures for the following. So the instruction's always gonna be the same. Just like with naming, just like with electron configurations, the instruction's always the same. It just says draw the Lewis structure. And we gotta figure out what to do. The goal is to make sure every atom is stable. If not every atom is stable, you have not made something that exists. Something unnatural. Talking about making molecules that are stable. Follow the steps. What's our first step? We've got how many oxygens? So write one on the left and one on the right. So O, O. By the way, what's O2? What is that? Anybody know what O2 is? Oxygen. It's specifically the oxygen we breathe in. We're breathing in oxygen right now, right? So we're looking at the molecular structure of what are we actually breathing that we need to live. Yes. Go ahead. Okay. All right. All of these molecules have some sort of meaning. They all have some sort of meaning. This is what we breathe. So what Oxygen doesn't want to have 6. He wants to have. So we're going to face 2 dots top, 2 dots to the side, and then one like this and one like that. Because remember, every side needs 1. On the other oxygen, 2 dots here. Where else would you put the pair? What's your suggestion? On the top or the bottom? Definitely not here, on the side. Top or bottom, which one you want to do? And like to the top. And then 1 here and 1 here. So far, so good? Yeah. All right, I'm going to bring something up. If you accidentally draw your pairs or your single electrons in the wrong place, can you move electrons around? Like, can you erase them and move them? Did I suggest using a pencil just in case, not a pen? Because there is a chance you accidentally visualize it wrong the first time, it doesn't work out, and you have to move the electrons around. So I want to bring up that electrons can be moved around the same atom. Meaning, you can move electrons around, for example, these 6 electrons, you can move around this oxygen, but you can't just say one of these electrons jumps over to that one, if that makes sense. You can move your pairs and your singles around the same atom. But this is good. Step 2, right? So we just did step 2. Step 3 is to bond your singles to make covalent bonds. So do you see a single electron here and a single electron there? All right, so we're going to bond that together. Is oxygen stable? How do we know it's not? That's why I said that's some extra thinking to do. When you do your count after you make that first bond, oxygen has 1, 2, 3, 4, 5, 6 for these 2, and then 7. 7's a no-no. Can't be 7, gotta be 8. So what can you do? Go ahead. And I suggest that. Because it'll be clean, right? If you move this, I agree with you. If you move this electron there, and that electron there, those 2 singles to the side, you can now connect those 2 and make a double bond. And you should do that. So I'm going to do that. Which is why I said use a pencil. It'll give you the clean version. And then these 2 will now connect. And we end up with, is this stable now? Because oxygen has 2, 4, 6, 8. This oxygen has 2, 4, 6, 8. This is stable. Happy? This is how oxygen exists. Yes?
Does it each have at least one electron?
This is to show, so if you look at the overall structure, these electrons are stuck between 2 oxygens. So no, they wouldn't, that's why I said you can move electrons around. If you just drew it the other way like this, you could do it like that. This is illustrating the same thing as this is. These 4 electrons are being shared now between these 2 oxygen atoms. So it's okay that you don't have any written at the bottom because you are showing that that electron is entangled with the other oxygen. They're stuck together. They're now being shared between the 2. Does that answer your question? Yeah. Okay. So I'm gonna erase this. And go on to the next one. CS2. Let's follow through the steps. See if we can do this next level 2 question. Okay, CS2. What's the first step? What goes in the middle? Carbon. Right? What goes on the side? Sulfur. One on the left, one on the right, unless you want to be spicy. And pick a different side. All right. That was step 1. Step 1, good. Step 2, now what? Valence electrons. Carbon has how many? Sulfur has how many? But we got to make that work out. They don't want 4 and 6. They want to have 8 to make the stable molecule. That's why they connect together, is to get to 8. Carbon, we're going to place the 4 the only way you place them, which is 1 on each side, right? And then for sulfur, I guess you have some decisions to make. Which side get pairs, which sides get singles. I would definitely face a pair away. And it doesn't really matter what you do here, because remember you can move electrons around the same atom. The one on the right-hand side, where would you like to place? Anybody can give me a suggestion, top or bottom for the other pair? What do you think? Okay, we'll do that. I'll roll with whatever is suggested. Because like I said, we can fix things like. So, what's step 3? Draw bonds between single electrons until each element feels like it has 8. So my suggestion is to bond one element at a time to the one in the middle to make sure that each element ends up feeling like it has 8 valence electrons. So sulfur to carbon, I'm going to do the left-hand side first. Do I see a single here and a single there? Can they mingle? Always. Habit. Is sulfur stable? Not yet. So what can happen now? Sulfur right now feels like it has 7, 2, 4, 6, 7, but it needs to feel like it has 8. So there's another single there, and there's a single there. So if you move them to the side, you can make a double bond. And so that's what we're going to do. We're going to move the 1 carbon electron to this side, and the 1 sulfur electron to this side. Because remember, you can move electrons around the same atom. Make your bond. And close the bond again. Now, is sulfur on the left-hand side complete? Is it stable? Is it good to go? No sulfur on the left-hand side. It has 2, 4, 5, 6, 7, 8. Ouch. So that's how I keep track. That's how I kept track of the students. I would like put a little check mark. Especially when you get to more complicated exams. It's good to like check to make sure you're good. Because once you're good, you shouldn't be doing anything else here. If you do anything else here, you're gonna mess it up. So I'm good with that. Now I have to bond not only carbon to this sulfur atom, I also have to bond carbon to this sulfur atom. So do we see any singles? There's a single there. There's a single there. What happens? Right? Connect those two. Are we good? We're not good. Because look at that carbon. That's not like a single electron right there. That sulfur's got a single electron right there. So what can we do? You can. You can move them around the same atom only. So you can move this one there, that one there, and then face them to each other so that they can bond together. And that's what you'll want to do. Which is why, once again, I suggest using a pencil, not a pen. You may wonder to yourself, hey, I don't know, some of you are taking Cambridge exams this year. Remember, Cambridge exams have to be written in what? Nope.
Pen.
Oh, pen. There's an exception for science on graphs and diagrams. This is considered a diagram. So you're allowed to use pencil for that. But for math, you actually have to write all math in pen for Cambridge exams. Like all formulas, all math, all English, all history, all pen. Just FYI. The only exception is graphs and diagrams, and that exception is in science. And I think if you have a graph in math, of course. All right. Are we good now? With CS2, is this a stable molecule as I have it right now? Yeah, this is right. 2, 4, 6, 8, 2, 4, 6, 8, 2, 4, 6, 8. We are good. What about the last one, N2? N2. First step is do what? One on the left, one on the right. Next step. How many valence electrons? N equals 5. So pairs away, single ones towards. Pairs away, single ones towards. If you write it the way that I tell you, that I suggest, do you kind of see what's going to happen here? What do you think is going to happen? Triple bond, right? because there's a single here and a single here, single there and a single there, and a single there and a single there. So technically you could do this, this, and this, but it's better if you move the electrons over. It looks nicer if you do it like this. Move the electrons over, and you get a triple bond. Now, there's something really, really important before we do the last type of level 2 that I want to bring up. Group 17 has how many valence electrons? 7. Every element in group 17 has 7, right? So here's my question to you. Can elements in group 17 make double bonds? Yes or no? Yes?
Believe, Francesca's going home.
Okay. Almost done. Let me give you the homework. Can't forget. Can't leave home without it. Good job. The baby come back from break. All right, so can group 17 make double bonds? Single bonds only. What about group 16? Can group 16 make double bonds? Yes. It can make single bonds or double bonds, right? Why can group 16 make double bonds? It can make 2 connections, right? To get up to 8, or it needs 2 more to get to 8, so it can make 2 bonds to do that. Group 15. Can group 15 make double bonds? It can make 2 connections, yeah? Can group 15 make triple bonds? We just saw it in the example, right? Because it can make 3 connections. So you should write that down. Based on the valence electrons that an element has, it tells you what type of bonds it can make. Group 17 can only make single bonds. So if you ever see an example on a quizzes where you see something like, they tell you, hey, does this exist? They won't say it exactly like that, but you'll see that. Does that exist? No. Iodine does not connect 3 times in any way, shape, or form. Iodine only connects once. This makes no sense whatsoever. Get out of here with that. You're wrong. Kind of makes sense? Yes. Yes. She was leaving. Here you go. All right, so this is a common type question asked, and now you can evaluate whether this is right or wrong based simply on this information. Anything in group 17 can only make single bonds. Group 16 can make single or double. Group 15 can make single, double, or even triple. So that's important. All right, we got one last scenario to cover before we're done with level 2. So you'll have seen every type of question that you could possibly see on the quiz. Obviously, you're not going to have a quiz next class. Not right after break. But you'll have one on December 1st, which is the Friday. We come back from break. All right, let's take a look at final scenario. Level 2. What do I expect? So level 1 and level 2 questions, I expect at the pre-AICE level that you can do. And Cambridge expects at the pre-AICE level, not the AICE level, not college level, this is still considered high school level possible. Level 2. What is the last level 2 scenario? What's going on here? What is that? What is this last scenario? It's called multiple central atoms. That means you have more than one atom in the middle of the molecule. You have a larger molecule than one central element. This is the final scenario. What do you think you do? C2H4. Think about it. How would we do step 1? Put the C's next to each other. Yes, that is absolutely correct. So the 2 carbons go next to each other because hydrogen cannot go in them. tears on your paper, you'll see two carbons. No hydrogens in the middle. So, two carbons in the middle. How do we put the hydrogens then? What would make sense to you? If there's two carbons and four hydrogens, I would say put two hydrogens on each carbon. Put them, yeah, like that. So maybe two like this, and then you could do like that. It doesn't really matter. Just put two hydrogens for each carbon. Step one. By the way, step one's the hardest in this scenario. You can figure out step one. The other steps will fall in line. What's step two? Step two, get those valence electrons. Hydrogen. How many? There you go. Monday when we come back from break. Hydrogen 1, right? Carbon in? Alright, 1-4. Hydrogen. Good with that? Carbon, 1, 1, 1, 1. Step 3. Bond single electrons until each atom feels like it has 8. Unless it types in 2. Single, single, mingle. Single, single, mingle. Good so far? Single, 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 single. And these two carbons in the middle. Mingle. Who's that? Carbon has 2, 4, 6, 7. Oh, 2, 4, 6, 7. Oh. How many does carbon need to have? What do we gotta do? Yes. So you see a single up there and a single up there. That means that these two carbons get a double bond. So, like I said before, use a pencil. Put those two electrons next to each other on their respective carbons, and you make a double. This is a molecule called ethene. We'll learn that when we learn organic chemistry. B. This is our last question. I want to talk about this molecule before we're done, but let's solve the question first before the call announcements. Hopefully. What's our atoms in the middle this time? Multiple central elements. What should be in the middle? The end. Oh, nice. Carbon ends. Oxygen go in the middle. Hydrogen can never be in the middle. Now, they are giving you a clue by the way they've drawn it. These three hydrogens should go with that.
Good afternoon, going live.
This is Ethan.
Ava.
I'll pause. And
Michelle.
then we'll finish with
Valentina.
And these are your afternoon announcements. Students, please remember to check your Cambridge email daily and report to school in proper TI uniform. Make sure your outerwear is solid black, white, or red. Also, please wear your student ID badge around your neck at all times. Detentions will be issued to students who do not adhere to uniform policy. Please remember that you must wear your student ID every day. If you lost your ID, the cost for replacement is $5.
If you receive a replacement ID, you must be put on OSP. Students who have unpaid balances will not be allowed to participate in field trips. Yearbooks are now on sale for $60. The price will increase after December 20th. Please visit www.yearbookordercenter.com to order. The order number is 21027. Students, please remember to turn in your family engagement survey ASAP. You can drop off your completed form in the mail office. Attention students, please pay close attention to this very important message. Tomorrow is Turkey Bowl. Please remember that booths will not accept cash. You must purchase tickets from Ms. Sanz Gomez. Tickets will continue to be sold tomorrow. Tickets are non-refundable after they have been purchased.
Okay, students, these are your instructions for Turkey Bowl tomorrow. I need everybody's attention so that later I don't hear that they didn't know. We will have Turkey Bowl tomorrow. Ms. Sanz Gomez is telling you it is not going to rain. We are going to have a great day tomorrow.
It's like 20%.
Tomorrow, 9th graders will be dressed in green. 10th graders will be dressed in blue. 11th grade in pink. And 12th grade in purple. And the teachers will be in orange. So everybody has their color tomorrow. Everybody can come dressed since the As soon as you arrive from school, you do not have to bring clothes to change. You can come in school in your assigned color. Shorts, leggings, jeans, joggers are all allowed. With that being said, your shorts must be school appropriate. Girls, we don't need to see it. Please wear nice school appropriate shorts. No biker shorts will be allowed. No exercise shorts will be allowed. No tank tops will be allowed. Cutoffs, shirts that are too short, showing your midriff. T-shirts with V's showing too much. Girls, we don't want to see it. Keep it at home, please. Okay? Tomorrow is a regular periods 2, 4, and 6 day, all going to happen before lunch. You will go to all 3 of your classes. They will just be shorter. As soon as the bell rings for lunch, everybody will go to lunch like normal. And then right after lunch, everybody goes to the auditorium. So students, when you go to lunch tomorrow, take all your things with you. You will report to the auditorium. And after the auditorium, we'll be going outside to enjoy all the booths and everything that the clubs have done at approximately 12:30 for the remainder of the day. And you will be dismissed from there at the end of the day to go home. All your book bags and belongings will be stored in the 700 building, which is the building that is behind the school, and we will be using the bathrooms back there, okay? No one will be coming back into our building once we go outside for Turkey Bowl. I will be selling tickets all day tomorrow, so if you have not purchased your Turkey Bowl tickets, just look for me. I will have them. I will be walking around with them. Anybody has any questions, or teachers or students, you know where I am. You can reach me.
There are 3 detentions after school today. Please be advised you need to report to Mr. Werwitz for detention on time. If you do not show, you will have detention double after Thanksgiving break. Also, Amanda Ochoa and Isabella Ochoa report to the main office.
And one last thing, students, if you come to school tomorrow out of dress code, you will not be allowed to go to Turkey Bowl. You will be staying inside with Miss Jadaim, who will be staying with the naughty children tomorrow. Thank you, and have a wonderful day. No, we're not done.
All right.
At 2:30 in room 259.
I
The
don't know.
card club will be meeting today after school at 2:30 in room 259.
All right. All right, let's wrap this up real quick. How many hydrogens go on the carbon? 3. What tells you? How many hydrogens go with the oxygen? Can I put that hydrogen here? Please don't. Put it on the top, the bottom, or the right. All right, step 2, what do we do? Valence electrons. Hydrogen is how many? Carbon is? And oxygen is? 6. So we're going to fill those in real quick. Hydrogen 1, carbon 4, oxygen 6. Like that. The 2 pairs facing away and the single ones towards. Now what? Connect all the singles and they all mingle. Now, I was going to tell you a little story about methanol. I've got about 2 minutes left. Methanol is this molecule. It's called methanol. Anybody ever heard of methanol? Or you think you have? It is a type of alcohol. It is not one that is drinkable. If you drank methanol, if somebody gave you methanol, it would be colorless just like drinking alcohol. And it would taste similar. But if you drink it, you go blind within 18 to 24 hours. And you can die. It has purposes. It's like used in antifreeze and stuff. So I'm going to pass you the homework before you go. Never drink anything anybody gives you at a party, is all I'm going to say. It's not home. It's not home. I gave you.
You told me.
All right, before you leave, get a copy of the homework. Do not leave without getting a copy of the homework. It's posted online, but you want the physical copy before you leave today. I need two already. Here you go. Before you leave, get a copy of the homework.
You gotta go.
Yes. Have a wonderful day. I'll see you all tomorrow.
Oh, okay.
Let's go. Okay. I'll be so sorry.
All right, I'll see you.
All right, have a wonderful day. If I don't see you tomorrow, have a wonderful Thanksgiving break.
You don't like orange?
Like I have like one orange shirt. I don't wear orange. All right, everyone have a wonderful day.
Dang, but I swear, that's when they called Kaylee Brother's office, she was speeding through the door.
It was just like a corrected version.
But you
Like,
just
I
did.
took it. Take it off because they took the E out of my name.
No, you're exempt from that one day. That you left early, or I think you left early that day.
Yeah.
If I recall correctly.